Tween service is amazing. It literally allows you to make clean, smooth-looking animations for your Roblox games. But using tween service alone for everything is limiting your potential. For example, let's say we want this frame to go from the leftmost part of the screen to the rightmost part. It's pretty simple with tween service. You get the tween service, you tell it what you want it to do, and you play the tween. And the frame smoothly goes to the right side. But let's say that you wanted this frame to curve from the leftmost part of the screen to the rightmost part. How would you do it using just tween service? It would be pretty hard, right? This is where tween service has its limitations. Tween service does a process called linear interpolation, where it draws an invisible line between what the current property is and what the goal is, and smoothly interpolates the instance from A to B. But if we want this frame to curve while going from one point to another, we have to be a lot more creative than tween service alone allows us to be. So let me introduce you to Bezier curves. Bezier curves are these mathematical curves that allow us to pretty much create whatever curve we want. And by using them, you can create even cooler looking animations, like this. But before we can learn about Bezier curves, we have to fully understand what tween service is doing behind the scenes, which is a concept called linear interpolation. So let's look at this number line. This number line ranges from 0 to 10. If I asked you what is the middle number that sits between 0 and 10, what would you say? Probably 5, right? How did you figure it out? Well, maybe one way is by saying if I divide this 10 by 2, then I get 5. So you solve 10 divided by 2 and got 5. That works great, but what about this? A bit tricky to figure this one out, isn't it? Well, the first step is realizing that the middle number will be equidistant from the left and right numbers. For example, let's assume that the middle number is 4. Then 4 is 4 minus 2, which equals 2 away from 2, and 4 is 10 minus 4, which equals 6 away from 10. Since 4 is 2 away from 2 and 6 away from 10, 4 definitely can't be in the middle. So maybe you try another number, like 6. 6 minus 2 is 4, and 10 minus 6 is also 4. Well, both of the results are the same, so 6 is definitely in the middle of 2 and 10. But what if we had numbers that were decimals? Then it gets way harder to do just based off of intuition alone, doesn't it? So we can use this formula for linear interpolation. In this formula, A is the number on the left, B is the number on the right, and T is the percent that you want to get in between A and B. For example, in this scenario, we want to figure out the number that is 50% in between 2.23 and 10.89. So we can just plug in the numbers onto our equation. Our A is the number on the left, the 2.23, our B is the number on the right, the 10.89, and our T is a decimal. So 50% is equal to 0.5, and that is our T value. And as a result, we get 6.56. That is the number that is in the middle of 2.23 and 10.89. And what if we want to find the number that's 25% of the way in between 2.23 and 10.89? In this case, we can just use the same formula, but instead of T equals 0.5, we will use T equals 0.25. So now that we understand how the formula works, let's apply it to Roblox. Say that we have this brown part here, and we want to make it fade away. With tween service, it's pretty straightforward. The transparency starts at 0 and ends at 1. But we're essentially going to make a small version of tween service from scratch so that we can understand how tween service works behind the scenes. So how can we make this work with linear interpolation? Well, remember that linear interpolation, or Lerp, allows us to get the number that's a percentage between two numbers. So let's say that we wanted to get this part to fade out using linear interpolation. First, we get our linear interpolation formula added into our code. When we're trying to make this part's transparency be half visible and half invisible, we usually write this, but if we want to do it using linear interpolation, we can write this. Here we're saying let the part's transparency go halfway between 0 and 1. That's where the 0.5 comes from. The 0.5 is the halfway. If we visit our number line, we can see that it'll give us a state where the part is 50% visible and 50% invisible. Now let's say that we want to make this part fade out. Then instead of getting the number that's directly in the middle, we want to get the number that's 1% in between 0 and 1. Then we want to get the number 2% between 0 and 1. Then we want to get the number 3% between 0 and 1, 4% between 0 and 1, 5% in between 0 and 1, all the way up to 100% in between 0 and 1. And just to show this to you guys in code, it looks something like this. We are literally telling Roblox, okay, find the number that's 1% in between 0 and 1. Wait 0.01 seconds. Okay, find the number that's 2% between 0 and 1. Wait 0.01 seconds, and on and on and on, all the way until it finds a number that's 100% in between 0 and 1. And we can take all of this and package it into a neat little for loop. And remember that all this is doing is it's moving that variable t down the slider from 0 to 1. And this is how tween service works behind the scenes to create this awesome fading effect. Now, of course, this is a really simple example that doesn't really need lerp. Mathematically, lerping t between 0 and 1 is just equal to t. But now we know what we need to know in order to understand Bezier curves. Alright, so let's finally talk about Bezier curves. A Bezier curve is a smooth mathematical curve that we can use in Roblox game development. For example, when you want an arrow to curve across the sky and attack the opponent, you can use a Bezier curve. Maybe you want to make an object go in a curvy path. Well, you could use a Bezier curve. Maybe you want a cool animation for your loading screen intro. You can use a Bezier curve. You can get really creative with things and optimize them, like this watch that I scripted for my game Battlemania. And if you have a live game on Roblox and you want to make your players feel more satisfied, Bezier curves become pretty useful. If you do, you might also want to work with big brands like Walmart, Tommy Hilfiger, or NASCAR. That brings us to the sponsor of this video, Geek. Geek is a data platform for all things brands and gaming, designed for brands, agencies, and developers. For Roblox developers, Geek offers the Integration Network, which allows Roblox devs to get a personal dashboard with insights on their games and be discovered by brands using Geek to find Roblox experiences and the developers behind them. Using the Geek Integration Network is a smart way for Roblox developers to monetize their experiences. Got a live Roblox experience and want to work with big brands? Check the link in the description and join the Geek Integration Network for free. Thank you to Geek for sponsoring this video. So remember linear interpolation, finding the point that's a percentage in between 2 points? That's also a type of Bezier curve. That one is known as a linear Bezier curve. Now you might be thinking, yo, that's a line, not a curve. Well, feel free to argue with the mathematicians. So we know that Bezier curves allow us to make any type of curve we want. So how do you actually use math to make curves? Let's say that instead of one line, we had two lines that are connected. So we have P0, P1, and P2. The lines are connected at P1. Now if we perform a linear interpolation from P0 to P1, and then we perform another linear interpolation from P1 to P2, and then we perform a linear interpolation of the result of those linear interpolations, and then we trace the result of that from t equals 0 to t equals 1, we get this red curve, which is our Bezier curve. Okay, I know that was a lot, but let's look at the equation so that you guys can understand a little bit better. So we first perform a linear interpolation from P0 to P1, and we call that A. Then we perform a linear interpolation from P1 to P2, and we call that B. Then finally, we perform a linear interpolation from A to B, and that C is our curve. Now, if we rearrange the above equations using some algebra, we arrive at the standard equation for a quadratic Bezier curve. So when you're reading some scripts, if you ever see this monster equation, it's the equation for a quadratic Bezier curve. Now, let's use this in Roblox. A quadratic Bezier curve needs three positions: P0 where it starts, P1 which is a value that modifies its path, we'll talk about P1 in a bit, and P2 where it ends. In this place, the red part's position is P0, the yellow part's position is P1, and the green part's position is P2. We'll use a for loop like we did before for linear interpolation. We'll get our t value, and remember that A, B, and C are linear interpolations. Roblox has a built-in linear interpolation function, and we can use it for the vector3 data type. Remember that there's three lerps involved. First we lerp P0 to P1, then we lerp P1 to P2, and C is the lerp of the previous two lerps. So C is our Bezier curve result. So we just have to make that fairy go over to C. And boom, just like that, our 3D Bezier curve is complete. P1, represented by the yellow part, influences the curvature of the Bezier curve. Generally, I have P1 set somewhere in the middle of P0 and P2 and elevated, which gives us this nice Bezier curve. And here's what the Bezier curve looks like with P1 being set at various positions. In the beginning of the video, I had asked you about getting the frame to go from the left to the right but with a curve. Now that we know about Bezier curves, we can actually script it. So here, the green frame is P0, the yellow frame is P1, and the red frame is P2. We want the green frame to curve and eventually reach the red frame, so I've created variables for them here. For this, I'll use the quadratic Bezier curve function, so that you can see that the crazy looking formula actually does work. Since we aren't explicitly using linear interpolation here, we have to decompose the absolute position into individual x and y coordinates and then perform the Bezier curve on them. This is pretty straightforward since absolute position is a vector2 data type. So we have a decomposed Bezier function which takes the positions of the frames, performs a Bezier curve on the x coordinates and a Bezier curve on the y coordinates, and then converts it into a vector 2. So that now we can use the decomposed Bezier function to get the Bezier curved version and set the frame.position to that. Note that this is the same thing that we've done with the 3D part. We're just using the formula without explicitly using linear interpolation. And just like that, we now have a frame that curves over to its destination. We could even get the frame to curve downward by changing the positions of the frames. We can manipulate the positions to make different types of curves, and this is all possible because of quadratic Bezier curves. Now you've probably noticed that a quadratic Bezier curve has 3 positional inputs to it, the P0, P1, and P2. They allow us to make basic types of curves, but what if you want to make even cooler curves? Then let me introduce you to, last but not least, cubic Bezier curves. Get excited. Remember that we got a quadratic Bezier curve by combining linear interpolations? If we do some math with 2 quadratic Bezier curves, we get what is known as a cubic Bezier curve. This makes Bezier curves even more powerful. This idea is captured by this formula for a cubic Bezier curve. And if you go ahead and simplify the equation, you end up with the explicit version of the cubic Bezier curve below. Notice that now, instead of P0, P1, and P2, we also now have a P3. That means that we need one more frame to capture this curve. Now let's start writing the script for it and let's see what we can create with this new type of Bezier curve. So I've added the explicit form as a function here, and we'll decompose the Bezier into a vector 2 just as we did for the quadratic Bezier. This is pretty simple. We just need to add the P3 vector 2 decomposition. And that's it. Now we have a cubic Bezier curve. Let's see what this thing produces. So with cubic Bezier curves, we now have an even finer control of how the curve is formed. And there you have it. That's Bezier curves for Roblox. You now have a mathematical understanding of linear interpolation and how you can build it up to get Bezier curves. As always, thank you for watching this video. Be sure to subscribe if you got some value from it, and I'll see you in the next video. And don't forget to check out Geek's link in the description.